So far, we have discussed about measures of central tendencies. They are arithmetic mean, median, mode, geometric mean, and harmonic mean. So these measures of central tendencies, arithmetic mean, median, mode, which condense the series into a single the value or single figure. So these measures of central tendencies indicate that the central tendency of a frequency distribution in the form of an average. An average is a single significant value which is used to describe a distribution. These averages tell something about the general level of the magnitude of the distribution, but they fail to show anything further about the distribution. So therefore, in order to avoid such demerits of arithmetic mean, median, and mode, measures of dispersions have to be used. So here measures of dispersion or measures of the variation, this is another the statistical the tool which is used uh, to study the indifferences of the items or values which are given in the series. And here the definition of measures of dispersion is that dispersion is the measure of the variation of the items. So according to A.L. Bowley, dispersion is the measure of the variation of the items. So according to this definition, we can say that dispersion is the statistical the tool which is used for measuring the variation of the items which are given in the series. And another the author which is defined the term dispersion, Simpson and Kaffa. So he has defined that the measurement of the scatterness of the mass of figures in a series about an average is called measures of variation or the dispersion. So according to Simpson and Kaffa, dispersion or measure of variation refers to measurement of the scatterness of the mass of figures. Measurement of the scatterness, so it is the process of measuring or the statistical the tool like dispersion or the method which is used to measure the scatterness of the mass of figures in a series about an average is called as measure of variation or measure of dispersion. ಅಂದ್ರೆ ಒಂದು ಸೀರೀಸ್ ಅಲ್ಲಿ ಏನು ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಅಥವಾ ಐಟಮ್ಸ್ ಅನ್ನ ಕೊಟ್ಟಿರ್ತಾರೆ, ಆ ಸೀರೀಸ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂಸ್ ಅಥವಾ ಐಟಮ್ಸ್ ಏನು ಸ್ಕ್ಯಾಟರ್ನೆಸ್ ಆಗಿದ್ರೆ ಅಂದರೆ ವೇರಿಯೇಷನ್ ಆಗಿದ್ರೆ, ಸೊ ಒಂದು ಐಟಮ್ ಒಂದು ಒನ್ ನಂಬರ್ ಇರುತ್ತೆ, ಇನ್ನೊಂದು ಐಟಮ್ ಟು ಆ್ಯಂಡ್ 10, 25, 3, 75, 90, 100. ಸೊ ಈ ಥರ ಒಂದು ಸೀರೀಸಲ್ಲಿ ಐಟಮ್ಸನ್ನು ಕೊಟ್ಟಾಗ ಆ ಎಲ್ಲ ಐಟಮ್ಸನ್ನು ಅಂದರೆ ಸ್ಕ್ಯಾಟರ್ನೆಸ್ ಆಗಿರುತ್ತೆ. ಅಂದರೆ ಡಿಫ್ರೆನ್ಸಸ್ ದೆರ್ ಈಸ್ ಎ huge difference in between one number to another number. So lot of variation from one number to another number. So such a case that the scatterness of the mass of figures are to be measured through means of measures of the variation ಅಥವಾ dispersion. ಒಂದು ಮೆಷರ್ ಮಾಡಬೇಕಾಗತ್ತೆ ಆ ಸ್ಕ್ಯಾಟರ್ನೆಸ್ಸನ್ನು. ಅದಕ್ಕೋಸ್ಕರ ಸೊ ನಾವು ಮೆಷರ್ ಆಫ್ ಡಿಸ್ಪರ್ಷನ್ ಏನು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ಅಂದರೆ ದೇರ್ ಆರ್ four types of measures of dispersion or the variation. They are range, quartile deviation, mean deviation, standard deviation. So these are the measures of dispersions or the variations which are to be used for measuring the scatterness of the mass of figures in the series about an average. Now methods of studying dispersion. So the dispersion can be studied with reference to two measures. They are absolute measures and relative measures. So the absolute measures are the range, quartile deviation, mean deviation, standard deviation. So these are the four important absolute measures which are to be used for measuring the inherent and the scatterness of the values or the items which are given in the series about an average. And with that absolute measures, so relative measures are also used for measuring that inherent means the variations of the values in the series. So absolute measures ke relative measures ಯಾವ್ಯಾವು ಅಂದ್ರೆ ರೇಂಜ್ಗೆ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ರೇಂಜ್, ದಿ ಕ್ವಾರ್ಟೈಲ್ ಡಿವಿಯೇಷನ್ಗೆ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಕ್ವಾರ್ಟೈಲ್ ಡಿವಿಯೇಷನ್, ದಿ ಮೀನ್ ಡಿವಿಯೇಷನ್ಗೆ ರಿಲೇಟಿವ್ ಮೆಷರ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ಮೀನ್ ಡಿವಿಯೇಷನ್, and the standard deviationಗೆ relative measure coefficient of variation. So these are the absolute as well as the relative measures which are to be used for studying the dispersion. Now, absolute measures are expressed in the same statistical the unit in which the original the data are given, and absolute measures are not useful in comparing two or more series. And relative measures are expressed in ratios or percentages, and they are used for comparing two or more series. ಅಂದರೆ absolute measures ಅನ್ನ which are expressed in the same statistical unit, ನಾವು statistical unit ಅಲ್ಲಿ ನಾವು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ, and the original data are given, and absolute measures are not useful in comparing two or more series. So two or more series ಅನ್ನ ಕಂಪೇರ್ ಮಾಡೋದಕ್ಕೆ absolute measures are not useful, but relative measures are expressed. So these measures are expressed in ratios or in terms of the percentages, and they are used for comparing two or more series. So relative measures ಅನ್ನ ರೇಷಿಯೋ ಅಲ್ಲಿ ಅಥವಾ ಪರ್ಸೆಂಟೇಜಸ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ, and they are used for comparing two or more series ಅನ್ನ ನಾವು two or more series ಗೆ ನಾವು ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ. So this is about the absolute measures as well as the relative measures. Now the absolute measure, one of the absolute measure or the method of studying, the first method of studying the scatterness of the way values given in the series, or the first method of dispersion to study the first method of studying dispersion is that the range. So range is the first method of studying dispersion, and here it is the simplest measurement of the dispersion. The difference between the largest item and the smallest item is known as range. So range anna, so this is the simplest the measurement, and this is the first method of studying the dispersion, and it is the simplest measurement of dispersion or variation, and it is the difference of largest item and smallest item, and it is defined as difference between two extreme items of the distribution. Two extreme items are, one is the largest item and another one is the smallest item. So therefore the difference in between these two is called as the range. In other words, range is the difference between the largest and the smallest items of the distribution. Now, the formula to calculate a range, range is equal to L minus S, where L is equal to largest item and S is equal to smallest item. So, relative measure corresponding to range is called the coefficient of range, which is obtained by applying the formula coefficient of range is equal to L minus S by L plus S. So therefore this is the formula to calculate the coefficient of range. Now, merits of range. So here we see that certain the merits of a range are it is the simplest measure of dispersion, and it is rigidly defined and the easiest measure of dispersion to compute or to calculate, and it is readily comprehensible, and it requires very little calculations, and it is useful in statistical methods of quality control techniques, and it is useful in studying the variations in the prices of share and the stocks. So therefore this is the simplest measure, and it is rigidly defined and easiest the measure of dispersion, and it is comprehensively comprehensible, and that requires little calculations, even that can be understood by even the non-mathematical person, and it is simplest the method of studying the dispersion. So therefore these are the various the merits or the advantages of the range. So as there are merits of the range, in spite of having these the merits of range, we can see some sort of the demerits of range. So demerits of range, or in spite of the uses of range, the range suffers from certain limitations or drawbacks. They are, unfortunately, it is not a stable measure of dispersion because it is affected by extreme values only. So this is the first, it is not a stable measure of dispersion, stable measure of dispersion allah, because it is affected by extreme values, and it is not a suitable measure of dispersion where class intervals are open in the distribution, and it is completely depending upon two extreme values but not on the other values, and it is not suitable for mathematical treatment, and it is very sensitive to the fluctuations in sampling size. So therefore these are some demerits or disadvantages of range. Now, calculation of a range. So as the calculation of arithmetic mean, median, mode, here also the range measures of dispersions are to be calculated under three aids. So they are in individual observation, discrete series, and continuous series. So here a range, the calculation of a range for discrete observations. So from the given values, difference between largest value and the smallest value will give the value of a range. So let us calculate the problem which has given here. Find out the range and coefficient of a range from the following values of x: 42, 47, 54, 64, so 72, 94, 96, 45 ಇಲ್ಲಿ values ಕೊಟ್ಟಿದ್ದಾನೆ. ಸೊ ಇಲ್ಲಿ ನಾವು we have to calculate range and coefficient of range. So here we take into account L and S, where L is equal to largest item and S is equal to smallest item only in that series. So L is equal to largest item 96 and S is equal to smallest item 92. Therefore R is equal to L minus S. 96 minus 42 is equal to 56. So this, that's why it is called as a simplest method of studying measure of dispersion, and coefficient of a range is equal to L minus S by L plus S. 96 minus 42 divided by 96 plus 42, therefore 96 minus 42 is equal to 54, and 96 plus 42 138. Therefore 54 by 138 is equal to 0.3913. This is what the value of coefficient of range. So r is equal to 56, coefficient of a range is equal to 0.3913, absolute measure as well as relative measure. Now compute the range and the coefficient of range of the series, and state which one is more dispersed and which one is more uniform. So series different series ಕೊಟ್ಟಿದ್ದಾನೆ, values of the variables ಕೊಟ್ಟಿದ್ದಾನೆ, and in first series values of the variables, for that x bar is equal to 15, and in second series x bar is equal to 15, and in third series also we had x bar arithmetic mean is equal to 15. So therefore in both the series the value of x bar is the same. So therefore having this the data, we have to calculate range as well as coefficient of range, and we have to state which one is more dispersed and which one is more uniform. So here central tendency is the same, but information differs. This is what the values which are differed from one series to another series. So x bar is equal to sigma x by n. This is what the formula to calculate x bar in the case of individual series. Now r is equal to, in both the series r is equal to l minus s, the formula which is same here, and r is equal to in first series largest item 17 and smallest item 13. 17 minus 13 is equal to 4. In second series 21 minus 9 is equal to 12. In third series 29 minus 1 is equal to 28. So therefore the values of range uh, are deferred 4, 12 and 28. Now coefficient of range is equal to L minus S by L plus S. So in first series L minus S by L plus S, 17 minus 13 by 17 plus 13 is equal, therefore 4 by 30 is equal to 0.1333. In second series coefficient of range is equal to 21 minus 9 by 21 plus 9, therefore 12 by 30, which is 0.4. In third series 29 minus 1 by 29 plus 1, therefore 28 by 30, therefore 0.9333. So this is what the values of the coefficient of a range. Now yeah, here from these values we have to state which one is which one is less dispersed and which one is more dispersed. So here by referring these values we can say that series 1 is less dispersed because the coefficient of r is very less than the others, and more uniform series, but more uniform, but series third is less uniform and more dispersed because there is a high in third series. Now calculation of range for discrete series. So for calculating range for discrete series, frequency column is ignored, and the calculation which is based on the values of the x variable only. ಸೊ ಕೊಟ್ಟಿರುವಂಥ ಒಂದು ಏನು ಡಿಸ್ಕ್ರಿಟ್ ಕೊಟ್ಟಿದ್ದಾನೆ ಆ ಡಿಸ್ಕ್ರಿಟ್ ಸೀರೀಸಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಮಾತ್ರ ನಾವು ತಗೊಳ್ಬೇಕು, ಫ್ರೀಕ್ವೆನ್ಸಿ ಕಾಲಮನ್ನು ಇಗ್ನೋರ್ ಮಾಡಬೇಕು. ಸೊ ಇಯರ್ x series ಕೊಟ್ಟಿದ್ದಾನೆ and frequency ಕೊಟ್ಟಿದ್ದಾನೆ. In finding the range, frequencies are never taken into account of the range. So here we should concentrate, we should take into account only the given values, and we have to ignore the frequency column. Therefore in the given series, or in given values, L is equal to largest item 42 and smallest item 6. Therefore r is equal to L minus S. 42 minus 6 is equal to 36. This is what the value of r. Now find the coefficient of range. Coefficient of range is equal to L minus S by L plus S. Therefore 42 minus 6 by 42 plus 6. Absolute measure with respect to relative measure is called as coefficient of range. Therefore 36 by 48 is equal to 0.75. This is what the value of coefficient of range for discrete series. Now calculate the range and coefficient of range for another discrete series. X value ಕೊಟ್ಟಿದ್ದಾನೆ x series means values ಕೊಟ್ಟಿದ್ದಾನೆ x and then frequency ಕೊಟ್ಟಿದ್ದಾನೆ. So for calculating range for discrete series, frequency column is ignored. So this is what already you know, that for calculating range and discrete series, only we should take into account, only we have to consider given values and we have to ignore frequency column. So r is equal to L minus S. R is equal to 261 minus 43 is equal to 218. So this is what the value of range. So, and then coefficient of range is equal to L minus S by L plus S. Therefore 261 minus 43 divided by 261 plus 43. Then by calculating, by simplifying that, we will have the value 0.7171. This is what the value of coefficient of range. Now calculation of a range for continuous series. So here in continuous series, the range is calculated. The range can be calculated by taking the difference between lower limit of the lowest class and upper limit of the highest class. Lower limit of the lowest class and upper limit of the highest class are to be taken into account. Frequency column should not be taken into consideration. ಫ್ರೀಕ್ವೆನ್ಸಿ ಕಾಲಮ್ ನಾವು ಇಗ್ನೋರ್ ಮಾಡಬೇಕಾಗುತ್ತೆ, ನಾವು ತಗೊಳಕ್ ಬರೋದಿಲ್ಲ. ಇಲ್ಲಿ ಲೋಯರ್ ಲಿಮಿಟ್ ಆಫ್ ದಿ ಲೋಯೆಸ್ಟ್ ಕ್ಲಾಸ್ and upper limit of the highest class. So here the problem is given. We have to calculate range and coefficient of range from the data. So from the data given, we uh, we can calculate range and coefficient of range. So here lower limit of the lowest class 10 to 20 is the lowest class. So from that lowest class, lower limit is 10, and 50 to 60 is the highest class. So from that highest class, we can take the higher limit. We can take into account upper limit of the highest class. Upper limit of the highest class. So therefore 60 is the upper limit. So therefore 10 and 60 are the values which are to be taken into account for calculating range and coefficient of range. Lower limit of the lowest class, upper limit of the highest class 10 to 20 and 50 to 60. So from that 10 and 60 are the values. L is equal to 60 minus S is equal to 10. 60 minus 10 is equal to 50. Now coefficient of range is equal to L minus S by L plus S. Therefore 60 minus 10 by 60 plus 10. 50 by 70 is equal to 0.7143. This is what the value of range and coefficient of range. Therefore this is the way. And another problem is there, we have to calculate range and coefficient of range. So in finding range, the frequencies are never taken into account. The upper limit of the highest class and lower limit of the smallest class are only taken into account. So therefore range is equal to r is equal to l minus s. So here lower largest item 170, upper limit of the highest class 160 to 170, in from in that class upper limit is 170, lower limit of the lowest class is 120 to 130, in that 120 is the lower limit. So therefore largest item minus smallest item 170 minus 120 is equal to 50 is the range. Now coefficient of range is equal to L minus S by L plus S. 170 minus 120 divided by 170 plus 120. So therefore difference is 750 by 290. Therefore 50 by 290 is equal to 0.1724. So this is the value of range and coefficient of range. So therefore this is the way in which we are going to calculate the values of both range and coefficient of range.